Alright, so here is part 2 of the video. We're going to look at end behavior of a function. So end behavior of a function, basically we look at what is your graph doing on the left side and the right side. Okay, on the left side of the graph, we say that x is going to negative infinity, meaning, that's where negative infinity is. And then we see what the graph is doing. So the graph is, on this one, is actually going down. It's going to, f of x, or your graph, is going down. So we just say negative infinity here. And then over here, what is your graph doing? On the right side, as x is positive, my f of x is going up. It's also is going to positive infinity. Okay, so basically whenever you read this x going to positive infinity, we say that this is the right side. Okay, as x goes to negative infinity, it's going to the left side. Over here, and there's some other things, notes over here, but I just wanted to point out these things over here. So on this graph right here, what is your graph doing on the left side? It says x goes to negative infinity, so it's on the left side right here. My f of x is going up. It's going to positive infinity. And then as x goes to positive infinity on the right side, my f of x is going down to negative infinity. This one right here, it says as x goes to negative infinity on the left side, my f of x is going up, so it goes to positive infinity. And then over here, as x goes to positive infinity on the right side, f of x is going up as well. So it's also going to positive infinity. Okay. And then the last end behavior we have here is on the left side, as x goes to negative infinity, my graph is going down to negative infinity. As x goes to positive infinity on the right side, my graph is also going down here, so negative infinity. So if you look at all of the end behaviors together, there's really just 4. Either you have opposite end behaviors, here it's going down, here it's going up, same thing here, it's going up and then going down, or we have same end behaviors. They both are going up or they both are going down. Okay? All right, so in this lesson, we have to be able to find all of these different things looking at a graph: the domain, range, increasing, decreasing, maximum, minimum, the intercepts, the zeros and roots, and then the end behavior. Okay, and I just put little notes here for you to look at how we find each of these and how we write it. Okay, so I'm going to refer back to this a lot. All right, let's look at our first example. So here's our first example. And then we're asked to, for this graph right here, we're asked to find all of these, all of these different things. All right, so the domain. Remember that the domain, we read from left to right, and it's only on the x-axis. Okay? All right, let's see. On the left side, you notice that the domain is not really starting at -2 because there's an arrow. It keeps going to the left. So the domain here is from negative infinity, and then it keeps going all the way to the right, and it's positive infinity. Another way we say this is all real numbers. To find the range, you read it from bottom to top on the y-axis. Forgot to write that here. So here, on the bottom right here, because of this arrow, because it keeps going down, we're going to say it starts from negative infinity on the y-axis and it keeps going all the way up. So it goes to positive infinity. So this is also the same thing, negative infinity to positive infinity, all real numbers. All right, increasing and decreasing. So for increasing and decreasing, we first of all only look at the domain, meaning we only look at the x-axis. That's where we get our numbers from. And then the first thing I like to do is look at the turning points or critical points, or hills and valleys. So I'm going to put a point right here. I'm going to put a point right here because that's where my function is changing directions, going from increasing to decreasing or vice versa. Okay, so right here, let's start from the left. So we see here my function from negative infinity, even though it's going down, it's also going to the left. So from negative infinity, only on the x-axis, it is going up. It's increasing up until here. So from negative infinity until, don't pick the 12, go make sure you're only looking at the x-axis. So from negative infinity to 0, it's increasing. It's increasing from negative infinity until 0. And remember, increasing, decreasing, always use open brackets. And then it changes here. It changes directions. It goes down. Where's my? It goes down here. It's decreasing. So I'm going to put that over here in this section. So it's decreasing from, again, don't look at the y-axis, only look at the x-axis, from 0 until x equals 4. And then it changes directions and it starts increasing again here. It keeps going up all the way from 4 all the way to not 7, but since it keeps going right, to positive infinity. So it's increasing again, so we use this union symbol right here, which just means and, from 4 until positive infinity. Alright, so this question is asking you to find the relative maximum and minimum and the absolute maximum and minimum. So let's see. Here you have a maximum because it's a hill, and then here you have your minimum. So we need to figure out if it's relative or absolute. So this one, it is not the absolute because it is not the highest point. This function keeps going up. So this one is a relative maximum. It actually doesn't have an absolute maximum or minimum. So we can say none here. And it has a relative max at, so when we're looking at the maximum and the minimum, you get the value from your y-coordinate. Okay? So over here, my maximum is at 12. And then it does have a minimum. My minimum is at y equals, I was about to put 4, y equals 0. X-intercepts and y-intercepts, those are the easy ones to find because it's right there on the graph. So there's an x-intercept right here at -2. And remember, when you're writing intercepts, you got to give it as a coordinate. So you have x-intercept at -2, 0, where your y is always 0. And then there's an x-intercept right here at 4, 4, 0. There's a y-intercept right here. The coordinate here is 0, 12. So for x-intercepts, your y is always 0. For y-intercepts, your x is always 0. And that's how I wrote it here. Okay. And then the zeros and roots, they're nothing but the x-intercepts. We don't look at the y-intercepts, we only look at the x-intercepts right here. And then the way you write it is always x equals. You don't have to write it as a coordinate. So there's a 0 at x equals -2, and there's a 0 at x equals 4. Same thing here. This is actually saying the same thing. All right, end behavior. Oh no, I should have changed this. Okay, well this should say positive infinity. I'll change it. Okay, so you have here as x approaches negative infinity. So whenever it says that as x approaches negative infinity, you're looking at the left side right here. So what is your graph doing on the left side? Well, it's going down. So we say x is going to negative infinity. And what is your graph doing on the right side? As x goes to positive infinity, my graph is going up to positive infinity. Okay, let's do one more example. And then, yeah. Okay, so let's look at this one. So we have here, it's asking for the domain and range. Domain, remember, we go from left to right. Well, they're both arrows on the left side and right side, so that's easy. That's just negative infinity to positive infinity, all real numbers. And then same thing for the range. At the bottom, there's an arrow, on the top it's arrow, so that means it's going from negative infinity to positive infinity, all real numbers. Okay, and then you have here increasing and decreasing. Okay, well, here if you look at it, my function is increasing throughout the whole thing. It doesn't have a critical point, it doesn't have a turning point, so it's always increasing here. So we can just say it's always increasing from negative infinity to positive infinity, and it's not decreasing, so it doesn't have a decreasing interval. Relative maximum and minimum, none, because there's no turning point, there's no critical points here, so we don't have any of those. X-intercepts, there is an x-intercept right here at 9, so to write that you would say 9, 0, y is always 0, and then there's a y-intercept right here at -3, so you would say 0, -3. Zeros of a function are just your x-intercept, but we just say x equal to, so x equal to 9, same thing here. X equal to 9. Roots are the same thing, and then the end behavior. So you have as x goes to negative infinity, this means on the left side. What is my graph doing on the left side? Well, it's going down, so there would be negative infinity. As x goes to positive infinity on the right side, it is going up to positive infinity. Alright, so I have more examples here that we'll work through. Okay. And I'll stop the video here.